Welcome to this EWRB Electrical Service Technician Training course. I'm Aria, an electrical tutor working with Whitroy. In this course, I'll guide you through all the topics covered in the EWRB Electrical Service Technician Exam Teaching Guidelines. Welcome back. In our previous lesson we looked at the legislative requirements for workplace safety, learning how the law, the ESA, and the Health and Safety at Work Act guide everything we do. Now we're going to turn that law into action. Today's lesson is Topic 8.16, Safe Working Practices. This topic is about how you carry out electrical work safely, step by step, from planning the job to testing it before energizing. We'll cover safe systems of work, isolation procedures, live work precautions, testing methods, and the difference between dead testing and live testing. Let's begin with Topic A. Topic A, the meaning of safe working practices. Safe working practices mean using methods that control risk and prevent harm while performing electrical tasks. It's not just common sense, it's a requirement under S/NZS 4836 and Regulation 13 of the Electricity, Safety, Regulations 2010, which states that all electrical work must be carried out safely. Safe work means more than just turning the power off. It means assessing hazards, planning your steps, isolating correctly, proving dead, and using proper tools and protective gear. Every job, from replacing a light fitting to servicing a motor, must follow the same structured safety process. Topic B, Risk Assessment and Planning. Now let's move to Topic B, Risk Assessment and Planning. Before starting any work, stop and ask, what could go wrong here? Under S/NZS 4836 Clause 2, you must perform a formal or informal risk assessment before touching any electrical equipment. Check for exposed live parts, confined spaces or damp locations, damaged insulation or wiring, and whether anyone else might be affected by your work. If the risk cannot be eliminated, it must be controlled, for example, by isolating the circuit, using barriers, or wearing ARC-rated PPE. Plan your job so you have the right tools, the right test instruments, and a safe way to verify supply. Good planning prevents accidents before they start. Topic C, Isolation Procedures. Now for Topic C, Isolation Procedures. Isolation means physically disconnecting the electrical supply so no current can flow while work is being carried out. This is one of the most important safe work steps in S/NZS 3017 Clause 2.2. Let's go through the spoken sequence for isolation. 1. Identify the correct circuit or equipment to be worked on. 2. Isolate the supply by switching off or removing the appropriate fuse or circuit breaker. 3. Lock out the isolation point using a padlock or hasp, one lock per worker. 4. Tag the point with your name, date, and warning message, do not operate, person working on this equipment. 5. Prove dead by testing that all conductors are de-energized using an approved tester. 6. Carry out the work safely. 7. Retest before re-energizing to confirm everything is safe. Never rely on someone else's word that a circuit is isolated, always verify it yourself. Topic D, Test before touch. Now let's move to Topic D, Test before touch. This phrase is the golden rule of electrical safety. It means that before touching any conductor or terminal, you must first prove it is not live. Here's the test before touch method as spoken steps. 1. Prove your tester works on a known live source. 2. Test the circuit you're about to touch, check between active, neutral, and earth. 3. Prove your tester again on a live source to confirm it's still working. This sequence ensures you don't get a false dead reading from a faulty tester or flat battery. Remember, a test that saves a few seconds could save your life. Topic E, Live, Work and Approach Boundaries. Now for Topic E, Live, Work and Approach Boundaries. Working live is extremely dangerous and should only occur when absolutely necessary, such as testing, fault finding, or commissioning, where isolation isn't possible. Under as/NZS 4836 Clause 3.3, live work must be justified by risk assessment, approved by a competent person, and controlled using insulated tools, barriers, and PPE. There are also approach boundaries that specify how close you can get to exposed live parts. Even at 230 volts, you must keep uninsulated body parts and conductive tools away from live conductors unless you are trained and authorized. If live testing is required, keep one hand behind your back, stand on an insulated mat, and avoid contact with earthed metal surfaces. Now let's move to Topic E, Basic Motor Testing. Topic F, Tools and Equipment. Now let's move to Topic F, Tools and Equipment. Always use insulated tools rated to at least 1000 volts. Check that handles are not cracked or damaged, and keep tools clean and dry. Test instruments must comply with Cat 3 or Cat 4 safety ratings depending on the circuit location. Before use, check the leads and probes for damage and confirm calibration is current. Damaged tools or meters can be as dangerous as live wires. Topic G, Dead testing versus live testing. Now for Topic G, dead testing versus live testing. Dead testing is done with the power isolated and proved dead. Live testing is done with the circuit energized, but only when absolutely necessary. Here's how to explain the difference out loud. Dead testing checks that the installation is wired correctly, earthed properly, and safe before the power is turned on. Examples include continuity testing, insulation resistance testing, and polarity testing. Live testing confirms that voltage, phase rotation, or circuit function are correct once power is restored. Examples include voltage measurement, load current measurement, and functional testing of RCDs or control circuits. Dead testing comes first. It's the safe part of the verification process under as/NZS 3017 Clause 2.3. Live testing only happens after all dead tests are completed and isolation procedures are confirmed safe. Always remember, test dead before you test live. Topic H, Permit to Work Systems. Now we'll move to Topic H, Permit to Work Systems. A permit to work is a written authorization that allows a person to carry out a specific task under controlled conditions. Under as/NZS 4836, a permit is required for high-risk jobs such as live electrical work, work near high-voltage equipment, or work involving multiple trades on the same system. The permit outlines what work will be done, who is authorized, what isolation points exist, and what tests and safety controls must be in place. No work should begin until the permit is signed and displayed at the work site. Topic I, Environmental Conditions and Housekeeping. Now let's talk about Topic I, Environmental Conditions and Housekeeping. Electricity and moisture do not mix. Always keep the work area dry, clean, and well lit. Avoid standing on wet floors or metallic surfaces. If you must work in damp or confined spaces, use RCD protection and extra low voltage tools where possible. Good housekeeping also prevents accidents. Keep tools tidy, cables off the floor, and ensure clear access to switchboards and exits at all times. Topic J, Re-energizing and final verification. Now for Topic J, Re-energizing and final verification. Once work is complete, do not simply switch on the power. First, inspect a circuit for loose wires, stray strands, and correct polarity. Then perform all dead tests again, insulation, continuity, and earth resistance. When you are satisfied, remove locks and tags, inform all workers, and re-energize carefully while monitoring for any abnormal readings. Final verification proves that the system is safe to return to service. Applied example, isolating and testing a motor circuit. Let's look at a practical example. You've been asked to replace a 3-phase contactor in a motor control panel. You identify the correct circuit on the switchboard and isolate it by opening the breaker. You place your own lock and tag on the switch handle. Next, you test all 3 phases to earth using your multimeter, there's no voltage present, confirming it's de-energized. You replace the contactor, recheck all connections, and perform insulation and continuity tests before re-energizing. When you power it up, the motor starts smoothly and the overload operates correctly. By following each step, plan, isolate, test, and verify, you've carried out the job safely and in full compliance with AS/NZS 4836 and AS/NZS 3017. Bringing it all together. Let's summarize topic 8.16, Safe Working Practices. We began with what safe working practices mean, controlling risk and following procedures every time. We discussed risk assessment, isolation, lockout tagout, and test before touch. We explained live work controls, correct use of tools, and the difference between dead testing and live testing. We covered permits, housekeeping, and re-energizing safely. Finally, we looked at a real example of isolating and testing a motor circuit. All these practices come directly from AS/NZS 4836 and AS/NZS 3017, which are your two main standards for practical electrical safety. Checklist summary. Here's a quick checklist to memorize. Plan, isolate, lock, tag, test, work, retest, energize. Repeat it. Plan the job, isolate the supply, lock and tag, test before touch, do the work safely, retest, and energize only when proven safe. Summary. To wrap up. Always assess risk and plan before starting work. Use lockout tagout and prove dead before touching conductors. Use insulated tools and rated test instruments. Understand the difference between dead testing and live testing. Follow permits, housekeeping, and re-energizing checks. That concludes topic 8.16, Safe Working Practices. In our next lesson, we'll move on to topic 8.17, Electrical Testing and Measuring Instruments, where we'll build on this foundation and learn in detail how to use meters, testers, and instruments safely for both live and dead testing situations.